Hello. Today we're going to expand our knowledge of imaginary numbers. We're going to talk about complex numbers. But in order to do that, we need to understand kind of what a real number is and what an imaginary number is, and we're going to combine the two. So real numbers are basically all the numbers that you already know. Any number that can be on a number line, positives, negatives, fractions, decimals. So just some examples. I could have 5. I could have -5. I can have 3.5. I can have a -2/5, right? So most of the numbers, any number that you can kind of conceptualize, those are our real numbers. Anything that I can plot within a number line. Imaginary numbers we just discussed, though, however, have that extra symbol with them. So it's when I have, if I were to have 5i, that's an imaginary number. If I were to have a -6i, so it can be positive or negative, right? So it can also be a decimal, right? I can have 3.5i or a -1/2i, right? So it's basically when I take the real number and I multiply it by a value of I, that's what gives me an imaginary number, okay? So complex is what this lesson is going to be about. Complex numbers is when I have a real number plus or minus an imaginary. So you can see this. So A represents my real number, and then the BI represents my imaginary. And the plus or minus doesn't really make any bit of difference. So if I put an example under each one of these, I can call this first one, let's say 3 plus 2i. Now, these are not like terms, so you cannot combine them together. So that sum is considered a complex number. I can also have something, let's say I come up with 5 minus 7i, right? That is also a complex number. You can't add or subtract the 5 and the 7 because of that I. So we always write our answer with the real number plus or minus the imaginary number. So we're going to do a whole bunch of examples within this lesson that are going to add, subtract, multiply these complex numbers together. So let's start with a little addition, right? So when I add, I am just going to combine like terms, okay? So when I do this, you can see I'm going to kind of highlight the real numbers in blue here. So I have a 5 and a 9. Okay, I'm going to kind of circle the imaginary numbers. I have a 7i and a -3i. So what I want to do is I want to add those together. So if I do 5 plus 9, I'll do that in blue. Hang on, let's change colors. I get 14, and then 7i plus a -3i. 7 plus -3 is 4. We'll do that in red. I, right? And then this is my solution. Now you can't combine the 14 and the 4 because, again, you can't combine real and imaginary numbers together with addition or subtraction. We're just combining like terms. Kind of think of it as like a variable, right? So we're just combining the terms with the same variables. So I got a few more examples, same way, right? So I can do -3 minus 10. So -3 minus 10 is a -13. That would be my real number. And then I can do a 6i minus 8i, which would be a -2i. And that is my complex number. All right, it's that simple. Oh, let's refresh. My slides didn't come up. Let's try that again. There we go. All right. So again, practice makes perfect. 4 minus, always pay attention to the operation that we're dealing with here. Make sure we're subtracting or adding when we're supposed to. So 4 minus 5 is a -1. And then 2i minus a -7. Now be very careful with your negatives here. If you do 2 minus a -7, that would be a 9i. And that is my imaginary number, -1 plus 9i. All right, so now there's no parentheses here, so you don't have to do anything special, just combining like terms. Don't overthink it. I want to combine 7 and a -5. 7 plus -5 is 2. And then 3i plus 6i is 9i. That would be my final answer. Okay, so you don't need parentheses in order to go through this. We're just combining our like terms whenever we're adding or subtracting. Same idea. 6 plus 8 is 14. -9i plus 4i is a -5i. And this is my complex number. Okay? Now, we got one more of these, and then we're going to do something a little bit more interesting. So again, 8 minus 12. Now careful, because I have 3 real numbers in this. So if I combine an 8, a -12, and a 6, so 8 minus 12 is -4, plus 6 would be 2. -2i plus 3i is a 1i. Okay, or you can also just write this as 2 plus I. The 1 is kind of implied, so you could do it either way. It's kind of like x is still 1x, I is still 1i. All right, so this one's a little different. Okay, so now we're going to kind of piece together something from previous lesson into this one. So what I want to do is I want to reduce each one of these radicals, and then I'm going to look to collect the like terms at the end. So if I have the square root of 9, this is the square root of 3 times 3. Well, we have a pair of 3's, right? So we know that property, square root of 3 times 3 is just 3. Then I'm going to go to this next one, right? So I have a minus. Now, we know it's going to have an I in it because of the negative out front. We're going to take that negative out. That's what becomes our I. And then 4 can be broken down into 2 times 2. Now, again, we have that property. The square root of 2 times 2 is just 2. So that's going to become a2i. Next, I have my plus 15. Well, there's not a whole lot to do there. So we're going to leave it as plus 15. And then last but not least, I have a minus. Now, again, this problem would have an I because it's a negative. And we're going to break down 25 into 5 times 5. So I get I times square root of 5 times 5 is 5. So we'll write that as a 5i. And then we just have to combine our like terms, right? So I have a 3 plus 15 is 18. And I have a -2i and a -5i gives me a -7i. So when you deal with these radicals, we need to reduce the radicals first, then collect all of our like terms together second. So let's try round 2. Okay, same idea. So I'm going to break down 36. Let's say 3 and 12. Then 12 can be 3 and 4. And I can actually break down that 4 a little bit more to be 3 times 3 and then 2 times 2. So I have 2 3's. I have 2 2's. So 3 times 2 is just 6. Now I'm going to do the same thing for my next radical. Now we know we're going to have an I. I can break down that 9 a little further to be 3 times 3, which gives me a 3i. I'm going to keep going. I have a plus 30. Well, there's not a whole lot to do there, so we can just say plus 30. And then last but not least, use a different color. I'm going to say minus, and then we know that there's going to be an I because I have a negative with that 49. If I break down that 49, I'm going to have 7 times 7. And I get I, or in this case, 7i. So I would say a minus 7i. So now I just need to collect my like terms together. So 6 plus 30 is 36. And then I have 3i and a negative 7i, so that's a negative 4i. And that would be my complex answer. Okay. Oh, I got one more. Okay, round 3. So I still have the square root of 36. Make sure this isn't the same problem. Okay, it's a little different, very similar. The square root of 36 is going to be, let's say, 6 times 6, 2 times 3. So I have the square root of 2 times 2 times 3 times 3, or the square root of 2 times 2, square root of 3 times 3, which is 6. Then in my next one, I have an I square root 25, or an I 5 times 5. Now, some of you already know what the square root of 25 is, and that's okay. But I'm going to get a plus 5i. And then for my next one, if I take this out, I have a minus I square root of 9 now. Break down 9 into 3 times 3. So I have a 3i. So we'll say minus 3i. And if I break down 81, it's 9 times 9. So let's use another color here. 9 times 9. I can break the 9s down into 3 and 3. 3 and 3. I'm going to break those apart, which gives me 3 times 3, or in this case, 9. So I have minus 9. So now let's combine all of our like terms together. So 6 and negative 9 is a negative 3. And a plus 5i and a negative 3i is 2i. This would be my final answer. Okay. All right. So now the next piece to the pie here is reducing powers of I. So there's a big property that I want to add into our lesson today, is I squared is a negative 1. Okay, anytime you see an I squared, we're going to substitute negative 1. So if you look at this problem here, I have 3 times I squared. So that's going to be 3 times a negative 1. 6i minus 9 plus 14i. Right? So if you look at that, now we can't change the i's. We can only change the I squareds. So I have a negative 3 plus 6i minus 9 plus 14i. Now we can collect our like terms together. The negative 3 and the negative 9 is a negative 12. And the 6i and the 14i is a 20i. And there is my complex number. Okay, so I have a few of these. Let's keep going. So again, anywhere the I squared is, that's going to become my negative 1. So I'm going to have a 2i minus 9 plus 7 minus 10. And instead of I squared, I'm going to put in that negative 1. So that's going to become a 2i minus 9 plus 7. And then negative 10 times negative 1 is a positive 10. Okay? So if you look, I have 3 real numbers. I can combine all 3 of those real numbers. So I have a 2i, negative 9 plus 7 is a negative 2, plus 10 is 8. Now, you can, if you wrote your answer like this, I would probably take it. But normally they write the real number first and then the imaginary number second. So just in case you were to see that on a multiple choice, I just want you to be aware. Okay? The I is with the 2, though. That's very important. All right, so I have a multiplication problem here. All we're going to do is we're going to distribute 4 times 8 is 32. 4 times a negative 2i is a negative 8i. 3i times 8 is a 24i. 3i times a negative 2 is a negative 6i squared. So we're going to use that property, that idea. So I have a 32 minus 8i plus 24i minus 6 times, and then I squared is a negative 1. So I have a 32. Now, I'm going to write this all out. Minus 8i plus 24i, and then negative 6 times negative 1 is a positive 6. We're going to combine like terms. So that gives me a 38. And then if I combine my i's together, negative 8i plus 24i would be 16i. And that would be my answer. So in a distribution problem, when you multiply, we tend to get these I squareds, but we know what to do with those I squareds now. We can change all those I squareds into a negative 1, right? So let's do it one more time. Negative 2 times 6 is a negative 12. Negative 2 times a negative 8i is a positive 16i. 5i times 6 is a 30i. And 5i times a negative 8i is a negative 40i squared. Don't forget your squared, because remember, I times I will give me I squared. All right, so 5i times 8i, 40i squared. All right, so now I'm going to rewrite this, except for when I rewrite it, instead of the I squared, I use that property that I squared is a negative 1. I'm going to then start to reduce it. And then negative 40 times negative 1 is a positive 40. And I can combine my like terms. Negative 12 plus 40 is going to be 28. And then 16i plus 30i is a 46i. And this would be my answer. Okay. Let's keep going. I think I got one or two more of these. Okay. So just practice, practice, practice. So 5 times 3 is 15. 5 times a negative 9i is a negative 45i. Negative 7i times 3 is a negative 21i. And negative 7i times a negative 9i is a positive 63i squared. Okay, so now we're going to write this instead of I squared. We're going to put in a negative 1. We're going to multiply that 63 times a negative 1 gives me a negative 63. Combine our like terms. 15 and a negative 63 are my real numbers. So let's see. 15 minus 63 is a negative 48. And if I combine a negative 45i and a negative 21i, I get a negative 66i. And this would be my complex number. Okay, I think I got one last one. Last one. So negative 8 times 3 is a negative 24. Negative 8 times a negative 3i is a positive 24i. 2i times 3 is a 6i. 2i times a negative 3i is a negative 6i squared. So I have a negative 24 plus 24i plus 6i, and then minus 6. Instead of an I squared, I'm going to put a negative 1. So I have a negative 24 plus 24i plus 6i plus 6. Combine my like terms. So the real numbers, negative 24 plus 6 is going to be a negative 18. And then 24i plus 6i is 30i. So I have my real number plus my imaginary number. That's my complex answer. And that is how we multiply complex numbers. Remember, I squared is a negative 1. So this is how we multiply complex numbers. And then up here, this is how we add or subtract real numbers. So if you look, okay, we just need to collect our like terms. Now, there will be problems where you need to reduce those radicals first. So please take your time with that and then combine any like terms you have at the end. Okay, hopefully this helped, and I'll see you in class.